how many integers from 1 to 8100 are not multiples of any of the factors of 8100? Let's look at 8100. 8100 is simply 3 to the power of 4, which is 81 into 100, and 100 is nothing but a 2 square into a 5 square. So you're looking at this. Now, if you're looking at factors of 8100, of course the factors of 8100 prime factors are 2, 3 and 5. Now you might want to say, sir, 6 is also a factor. Fair enough, 6 is also a factor. What will be the multiples of 6? 6, 12, 18, all of those will be multiples of 2 as well, right? So we need to only be concerned about the prime factors of 8100 and not all the factors of 8100 is what we need to understand at the first place. Now, if you are looking at the multiples of 2, in the number from 1 to 8100, how many multiples of 2 will be there? There will be 4050 multiples of 2 will be there. All of those multiples need to be removed. So how many numbers am I removing from this as of now? 4015 multiples I'm removing as of now. What about the multiples of 3? Let's look at the multiples of 3. In 8100 numbers, how many multiples of 3 are there? 2700 multiples of 3 are there. Out of these 2700 multiples of 3, 1350 will be even numbers and 1350 will be odd numbers. These 1350 even numbers have already been removed in 4050, so I cannot remove it again. So what more numbers do I need to remove now? Unique numbers that I need to remove, 1350 unique numbers. Now look at the multiples of 5. Now if you look at the multiples of 5, how many multiples of 5 will be there? Let's calculate this. 5 ones are 5, 30, 5 6 are 30, 16, 20 multiples of 5 will be there. Out of the 16, 20 multiples of 5, 810 will be even numbers. Those have been already removed in 4050, correct? Now, you need to look at the multiples of 3 also. Now, multiples of 3 and multiples of 5 would mean multiples of 15. But another catch that you need to understand is multiples of 15 is fair, but the even multiples of 15 have already been removed. So those cannot be removed again. So I'm counting over here odd multiples of 15. Let's check how many multiples of 15 are there in 8100. If I look at the multiples of 15, 15 5s are 75, then you have a 60, 15 4s are 60. So you have 540 multiples of 15. Out of these 550 multiples, 270 multiples will be even multiples and 270 will be odd multiples. Even multiples have already been removed, so I'm not going to remove this. So you are left with what? 270 multiples that you need to further remove, correct? So out of these 810 multiples which were left over here, which were after the even numbers have been removed, out of that also 270 multiples need to be removed, which were the multiples of 15. So you remove a 270 from here. So what are we left with? A 0, 11 minus 7. That will give you a 4. And 7 minus 2 will give you what? A 540. So 540 numbers are the unique multiples of 5 which have not been counted in 2, which have not been counted in 3 also. So 540 numbers further need to be removed from this. So total how many numbers do we need to remove? We need to remove a 4 over here and 5 and 3, 8, 5, 9, 4, 0 numbers we need to remove out of 8100. So out of 8100, if I remove 5940 numbers, I'll be left with 2160 numbers. So how many numbers are not the multiples of factors of 8100? 2160 numbers.